This is a demo presenting our paper, Structure and Appearance-Rich Training-Free Spatial Control for Text-to-Image Generation. In this work, we focus on text-to-image generation with condition control. Given a condition image of any modality and a text prompt, the goal is to generate an output image that inherits the structure of the condition image and aligns with the prompt. To control the structure of the generated image, recent training-free approaches such as plug-and-play and Control-X adopt a feature injection strategy, showing promising performance. Specifically, at each time step in the denoising process, these methods directly inject the condition image's features from the same time step into those of the target image. However, these methods often suffer from structural misalignment. Condition leakage and artifacts. Empirically, we observe that these failures become more pronounced when the condition image deviates significantly from natural RGB images, as shown in the figure. This suggests that a key challenge lies in the domain gap between the condition and natural image distributions in the feature space of the pre-trained T2I diffusion model. To validate this hypothesis, we conduct a quantitative analysis. As shown by the green curve, the domain gap between condition images and natural images narrows with increasing diffusion time steps. However, this improved domain alignment comes at the cost of reduced structural fidelity. As shown by the orange curve, structural preservation deteriorates with increasing diffusion time steps. We further conduct principal component analysis on the features, which shows that the primary structural information intended to be preserved emerges in the middle stage, while modality-specific details become more prominent in the late stage. These observations highlight the limitations of previous methods. As the sampling schedule progresses, the early features convey only core structural cues, whereas late features introduce out-of-distribution details in the output image, leading to structure misalignment and condition leakage. To the end of reaching a better balance between structure alignment and domain gap, we generalize the sampling schedule of condition features, decoupling it from the denoising process. Rather than injecting features from the same time step during the denoising process, we relax this constraint and introduce a principled framework that enables flexible, structure, and appearance-rich control. Our approach comprises three key components. Structure-rich injection injects condition features based on a principled schedule, with a better balance of structure preservation and domain alignment. Restart refinement schedule performs iterative refinement in the mid-phase of the denoising process to suppress visual artifacts in time and improve overall image fidelity. Appearance-rich prompting enrich the original plain prompt with visual cues from the condition image, providing accurate semantic reference for appearance image generation and appearance transfer. To evaluate the performance of our pipeline, we conduct extensive experiments. Our method effectively addresses key limitations of prior work, including structure misalignment, condition leakage, and artifacts, and achieves SOTA performance among all training-free methods. In the radar chart, greater distance from the center indicates superior results. On reward model-based metrics that are aligned with human preference, including DreamSim, Image Reward, and HPSV2, our method demonstrates a clearer superiority. As shown in the figure, training-based methods only support limited types of conditions, and often fail to adhere to the text prompt. Among training-free methods, guidance-based approaches, such as free control, often produce blurry and dim results with limited structure alignment. Feature injection-based pipelines, such as Control-X and PNP, are prone to condition leakage, producing outputs that closely resemble the condition image. These methods also often suffer from structure misalignment and artifacts. In contrast, our method consistently outperforms these baselines in structural preservation, text-image alignment, and visual quality, excelling in difficult scenarios such as challenging prompts. Abstract conditions and multi-object scenes. Additional qualitative results further demonstrate the versatility and robustness of our approach under diverse conditions. More importantly, We systematically explore different forms of injection schedules G, T, and evaluate their impact on structure alignment and visual fidelity. Our ablation on linear schedules from A to D reveals a clear trade-off. Schedules biased toward larger time steps like A weaken structural alignment and increase DreamSim scores, whereas those biased toward smaller time steps such as C and D degrade both visual quality and structural fidelity due to excessive modality-specific cues. In contrast, the medium time step schedules, B, strike a favorable balance, yielding stronger structure preservation without sacrificing visual realism. Beyond linear functions, we further examine a family of schedules, from E to I, that share the same final time step but differ in monotonicity, convexity, and initialization. Interestingly, all of them deliver consistently strong performance, suggesting robustness to functional variations. Empirically, we find that convex functions slightly outperform concave ones, and even a constant time step schedule achieves competitive results. Guided by this observation, we adopt a constant schedule for all subsequent experiments. Another ablation study, focused on appearance-rich prompting, shows that the module effectively adapts the prompt to semantically align with the condition image. The resulting appearance image captures key visual attributes, such as object size, visible parts, spatial layout, and shooting angle, thereby preventing incorrect appearance transfers from surrounding objects and minimizing visual artifacts. We also conduct an ablation study of restart refinement. The mechanism mitigates both condition leakage and appearance artifacts, leading to improved generation quality while preserving strong structural alignment. Thanks for watching.